So if I have a construct like this, so here in the for loop, I need to read the value of z every time it enters the loop, right? So if then the reason for that is I don't know where the z is pointing to. It might be pointing to the same location as x is pointing to. So the compiler cannot optimize this for C language, but it doesn't know whether this and this pointer are pointing to the same location. But if I tell the compiler in some way that these are not pointing to the same location, or there is a language that doesn't allow this kind of aliasing of memory where two pointers can point to the same location, then the compiler can optimize this much better because it will read this outside this loop only once. So these are the kind of language dependent and language dependent optimizations that can be done in the compiler. And machine dependent and machine independent. And these are really assembly level stuff. For example, if you have an instruction like loading some value to a variable, right? So if this is a simple instruction which can be done in two ways, right? One is you can really load, you can have an instruction which will store a value of 0, or load a value of 0 into this register, right? Or you can have an instruction which will XOR the same register with itself. So depending on which architecture you are talking of, one of them is more optimized. For example, if it is a CISC architecture, then this instruction will need more number of bytes for the instruction itself, which will make it less optimal. So the compiler for a CISC architecture will most probably do this in this fashion because it doesn't need any other input or any other constant inside the instruction. Next is the levels of optimization that a compiler can do, and as I said, one is the basic block optimization, which is completely inside a particular code block. Other kinds of optimizations are which is done inside a function and outside a function or inter-function, which is called as inter-procedural, and global kind of optimization. So all these and the complexity is in the order of what I said. A basic block of optimization is very simple to do. It's like what I said, optimizing a for loop unrolling, and things like that, and optimizing the switch cases. So those are basic block optimizations. Optimizations which are done inter-procedural are depending on when the function gets called. Is it okay to inline the function or not inline the function? When can I inline the function? And global optimizations are, it considers the entire code. So it is an optimization that at the end it is done in the compiling process. And another thing that we need to consider is about linking, whether you need to link it statically or dynamically. They have their own advantages and disadvantages. Dynamic linking will obviously make your object code much smaller, but it might affect the load time of your executable, because it might need other libraries to be loaded before your library gets loaded. And static linking makes it much faster, but the size might be more. And pre-linking is in between dynamic and static, right? So pre-linking is kind of your direct map cache, right? So if you remember in the direct map cache, what you do is you know that in the main memory where a particular page is going to come, right? So you don't have to calculate where the page is going to come at runtime. So similarly, when you do a pre-linking, you define the memory address where a particular library has to come. So if it's a very commonly used library, you don't have to calculate at runtime. The loader doesn't have to find out which is the best place or which is the available address to put it. So you define the address before for a commonly used library, and it gets loaded there. So any other module that needs that library can just pick it from there. So that is pre-linking. And pragma is a way of telling the compiler that you know better about your code than the compiler, right? So the example I gave here was about optimizing the variable that gets read. So if there is no memory aliasing, then you know that the compiler will optimize the reading of a variable. It will read only once, not inside the loop. But if it is a C compiler, then it won't take that chance because it is not aware that your memory is not aliased. So you have a pragma using which you can tell the compiler that, okay, I know it is C program, I know the pointer can point to the same place, but I am aware that in this particular code it won't happen. So if you give that pragma to the compiler will optimize the code. So this is a way of telling the compiler that you know better about your code. And finally the compiler options. So you'll have to go through the compiler manual to find out what are the available options. For example, in GCC, if you say -00 or -01 or -02, there are a set of options, there are a set of optimizations that are done by default. But you might want to take all the options of O2, but you want an option of O3. So there is a way where you can override that. So you can just tell the compiler that I want all the options of O2, but I just want one option of O3. Right? So all this depends on how much you know about your compiler. And the last thing is, this is called as just-in-time, and this is by getting best of both worlds. Right? So we know there are interpreters and there are compilers. Interpreters have their own advantage, compilers have their own advantage, but just-in-time compilation it's done at runtime. So this is used in Java, and the JVM is going to compile your bytecode into the actual machine code at runtime. So it has previous statistics of what is good and what is not good, how many times a function is getting called. So knowing all those statistics, it can compile your code much better than a static compiler, which is done before your code is loaded into memory. So yeah, this is a good thing to have, but it's not available on all mobile platforms as of now. But there is a plan to have it. For example, Android doesn't have it right now, but they'll surely have it very soon. Yeah. So next is about the design optimizations, and I feel this is the best place to optimize if at all you have to do it, because platform and compiler decisions, maybe yes, you will be involved to some extent. Coding optimization, yes, you will finally do it, but design optimization is a place where you can get maximum benefits. So there are, I just take a couple of examples of how you can optimize it. So threading is generally used for optimizing applications which need user interactions, and it's best to have the user interaction to be running in a separate thread, because you might be doing some background computations or writing the files and all that in a separate thread, but when the user wants to select an option, you can't delay the response because something else is going on in the same thread, right? So it is best to have the user interactions and all less time-consuming activities in one thread, so that the user does not perceive. Again, it comes to the perceived performance, right? So if your application is not responding, even though it is not doing any great job in the background, the user will feel that the application is blocked or it is choked, even though you are not doing anything great. So if there is anything that really consumes time, like a heavy computation or writing to a file, so move that into another task or another thread, and you can have all the user interactions to be done in one thread. And next is about the file operation choices. You'll have the basic file APIs that are provided by any file system, and they may or may not be buffered. So, but it's good to buffer writes when you write the files, right? Because irrespective of what file system you're talking of, maybe it's an external memory or internal memory, it's always better to write it in huge chunks, because the writing itself has a overhead in that, and once you have taken care of the overhead, it is better to write as much as possible into the file system. So when you're writing, some file systems provide buffered writes, so you don't have to take care of it in your application. But some file systems which are generally proprietary, they don't allow buffered writes. So you'll have to take care of that in your application or in your code. So you'll have to buffer the writes before you actually write to the file system. And again, here when you are writing, okay, it depends on how much time it takes to write. You'll have to profile that.